101, Mr. Herman here. This is the practice test for trigonometry. Let's jump straight into it. Multiple choice questions here from 1 to 7. First question, the value of sine 22.21 is equal to. This one, grab a calculator out, work out what the sine of 22.21 is. And here our ratio is 0.378. Looking for 0.378. This one here wants to be. Question 2, the value of tan 54.39, same process except we're using tan 54.39, 1.396. So 1.396 is C, not 1.369, it's 396. So this here is also C. Oh, not also C, B and then C, sorry. Question 3, if cos of the angle is 0.93, then the angle is closest to what? This is where we have to use our inverse sine. So if the angle is the unknown, so we have to find out what cos inverse of 0.93. Now, this isn't obvious because what we're so used to is this ratio here being in fraction format. This is just showing it in the decimal format, which is completely fine because technically that's the same as 93 over 100. But the process is still the same. Shift cos to get inverse and 0.93. This will give us 21.56, which is 21.6 as the critical digit here. 6 bumps is 5 to a 6, so it's 21.6. Too many number 6. There we go. So 21.6 degrees is the solution for this one. Same process again. Inverse of sine, question 4, and we're going to put 0.45, and this will give us 26.74368, etc. So 26.74. It's our solution here. Select the correct statement about this right angle triangle here. So this one is a bit small, so I'll just write them out a bit bigger. This is B, that's theta, B, C, and A. So obviously we can form our 3 different trigonometric identities depending on what letters we use. So I know that if that is the angle of interest, this one here will be our opposite, this one here will be our adjacent, and C will always be our hypotenuse because it's opposite the 90-degree angle. So sine of this angle will be opposite over hypotenuse, so A over C. So can we see a sine as A over C? No. This one says sine A over B, so it can't be this one. And there's no other sine, so let's look at the cos. So cos is adjacent over hypotenuse, so it will be B over C. So can we see a cos B over C? This is cos A over B, and this is cos C over B. So it has to be one of the tangents. Tan of this is opposite over adjacent, so A over B. We got B over A and A over B. D is our final solution. Okay, so remember I'm just using the SOHCAHTOA, and I'm replacing the appropriate side lengths of the angle into this little saying, I guess, determine whether sine, cos, or tan relates to these letters, and then trying to find it based on what's being given. Question 6, the length of side Y is closest to. So we have an angle 57, the opposite, and the hypotenuse has been provided. So here we're using the option of sine. So sine of 57 degrees is equal to opposite over the hypotenuse. To get Y, we just simply times this by 15. So on the calculator, 15, let's move this across, there we go. 15 times sine 57, and this is equal to 12.58. So 12.58 is our solution here. The length of side BC is closest to. So BC, if this is B and this is C, so this is the line that we're looking for, which is a hypotenuse. what we've been given is the angle and the adjacent. So here's the adjacent, here's the hypotenuse, which we don't know. A and H uses cos as a trigonometric identity. So the cos of 35 degrees is equal to A, which is 12, or H, which is our unknown. In order to get H, you just flip these two around. So to get H, we are working out 12 over cos 35 degrees. And this is 14.649, 14.65. So B is our solution. We're now going to approach the short answer section. The first one here for question 8, we're going to be looking at the true bearings. So we're going to write the true bearing for each of these points from the origin. So from the origin just means that from the origin we're going to go from here and we're going to rotate true north to A, B, C, and D, given what little clues, the little measurements or angles that have already been provided. So for A, we are looking from here to here, rotates around. If we already know that this little degree here is 30, then that has to be the difference between 90 and 30, which is 60. So here, this is 60 degrees true north. The second one is rotates from here all the way to there. So it's the 90 plus the 50, so it's 140. For C, we rotate all the way around until we get to there. There are two ways of doing this. You can have 180 and then add the difference between 90 and 20, which is 70. Or you can do a full rotation of 90, 180 to 70 and then take away the 20. I prefer the second, the latter, because it's easier numbers to deal with. So 270, but then you just backtrack by 20 degrees, so it's 250. The last one rotates all the way around until we get to D. In this case, I'm going to do 270, so 90, 180, 270, then add the extra 40. So 270 plus 40 is equal to 310. Question 9, we're going to find the value of the unknowns in the following right angle triangles. It's just a varying triangles. You will need to show what trigonometric identity that you're using. We're either trying to find side lengths or angles. So what I'm going to do is, instead of going through each one step by step, because by now you should be able to know the trigonometric identities at the back of your head, I'm just going to pause this, write it all out, and you can just have a look to see if you've got yours correct. Because this hasn't given the convention of what to do it in, just assume as to 2 decimal places. Okay, so 2 decimal places. The actual test itself will make sure that it shows you the required amount of decimal places that are needed. With the power of video editing, here are the solutions. All of them are angles except for the first one, 9.46. Make sure you write the centimeters there. 32.01 degrees for B, 47.86 degrees for C, 60.07 degrees for D, 45 degrees for E, and 29.74 degrees for F. Alright, question 10. A piece of plywood that is 9 meters long rests against a brick wall. The angle between the plywood and the ground is 27 degrees. What is the height of the brick wall? So let's draw this out. We have a plywood that is 9 meters long, and this rests against a brick wall. So obviously a brick wall is vertical. There's a brick wall. And the angle between the plywood and the ground, so the plywood and the ground, this is the ground here. So there's a brick wall, there's a ground, we have an angle here of 27 degrees. And what we're looking for is the height of this brick wall. So in relation to this angle here, we're looking for the opposite side. and the other side that has been given, which is the length of the plywood, is our hypotenuse. So we're using this sine of the angle. So sine 27 degrees is equal to the opposite, which is what we're trying to look for, over 9, which is the hypotenuse side. To get O, we just simply get 9 and times this by sine 27. This will give us opposite side, or the height of the brick wall. So O is equal to, so we've got 9 sine 27. This is 4.0, 4.085, so 4.09. Okay, so therefore, the height of the brick wall, you've got to make sure that it is worded solution, because it is a worded question. So the height of the brick wall is 4.0. Question 11. The idea for a crazy zip line to be put at the top of a high-rise building to the ground can be done as long as the building height is above 80 meters. Can the crazy zip line be made? Show all your calculations. This is what happens when you're creating a practice test at 11:30 at night. Come up with some delirious type questions. Okay, so this is obviously the zip line. It goes from point A to point C. We have 60 degrees here and 15 meters from the base of the building to on the ground to where the zip line ends or starts, depending on which way you're going. Generally it goes from top to bottom. So we have to see if this building is above 80 meters. If it is, they can put this crazy line. So what we're looking for is this height here, which is the opposite side of the given angle, and the other side that has been given in relation to the angle is the adjacent side. So we'll be using tan. In other words, tan 60 degrees is equal to the opposite, which we don't know, over 50, which is the adjacent side we do know. To get O, it's just 50 times tan 60 degrees. So our O, or opposite side, 60 rather. No, I was correct. 50, tan 60 degrees. Now if you get this, just make sure that you press your SD button, which is 86.60, so 86.60 meters. Now this is above 80 meters, so can the crazy zip line be made? Therefore, yes, zip line can be made. As height is above 80 meters, and in brackets we show 86.60. We just show what our calculation happens to be. So it's above 80 meters. It can be done. Whether you do it or not is another question. Alright, question 12. A lighthouse light shines to a boat out in the ocean. The angle of depression of the light to the boat is 42 degrees. If the length of the light beam is 112 meters, what is the height of the lighthouse to the nearest meter? So different approaches of how you use this, and there's different trigonometric identities. The way that I would approach this, there's no wrong way, but the way that I would approach this is if I were to draw the lighthouse, which is here, the light beaming to a boat. So here's my boat, and then obviously there's ground, there is the ocean. All right, so we have a lighthouse, and what we do know is a angle of depression of 42 degrees and a beam of 112 meters. So this is the light beam, which is 112 meters, Now, you got to be careful with your angle depression. This is saying that the angle of depression of the light, so the light being on the top here, to the boat. So this is saying that if this is my horizontal, then from there, depressed downwards will give me a degree 42. This right here is 42 degrees. Now, I've seen some students tend to write this as 42. This is saying that this here is 42, meaning that this angle here has to be the difference of 90 and 42. Okay, so just be careful that this angle here is not 42. This angle here is a difference of 90 and 42. And just to make sure, 90 take away 42, 48. So this here is 48 degrees. Okay, and so a right angle is formed here. And what we're looking for, if the length of the light beam is 112 meters, what is the height of the lighthouse to the nearest meter? So we're looking for this length here. So what we have been given in relation to the angle is what we're looking for, which is the adjacent, and the length of the light beam, which is the hypotenuse. Okay, apologies, I don't know if you've noticed, but I just had to deal with the plumber that was here, who just pulled out a helicopter out of Monty's toilet. Anyways, so where was I up to? Okay, we're looking for the height of the lighthouse. We have been given the adjacent and hypotenuse, so we're using cos. So the cos of this angle here, so cos of 48 degrees is equal to the adjacent, which we don't know, which is the height of the lighthouse, over the hypotenuse, which is the light beam, which is 112 meters. So to get A is 112 times cos 48 degrees. A is equal to this. Calculator, we need 112 cos 48, and this is equal to 74.94. So to the nearest meter, that is 75 meters. So 74.94, which is 75 meters. So therefore, the tower, or the lighthouse tower, therefore, the height. There we go. The height. The lighthouse is approx 75 meters. Question 13 has to do with bearings. We have a yacht that sails for 20 meters on the bearing 300 true north. So here we can have, here is our origin. We mark 300 degrees true north, and then from the origin it takes off for 20 meters. We're going to use this diagram to help us find the distance that it has traveled directly up north and directly west. So if I were to extract this triangle from here, having this as our origin and it going for 20 meters here, this being 90 degrees, we need to figure out what this angle is here in relation to the 300 degrees. So we know that this goes 270 degrees here. If it goes 300, we're finding the difference between 270 to 300. That will give us this little angle within here. So the difference between 270 to 300 is 30 degrees. So this angle here is 30 degrees. And what we're looking for is if it's what its length is or distance is from the origin to north. So if this is 30 degrees, this is 20 meters, we are looking for this length here, which is the north part. So that length here is the opposite length that we're looking for. And for west, again, if this is a 30 degrees and this is a 20 meters, we're looking for the origin directly left or directly west of where it started. So we're looking for the adjacent in relation to this. So for the first one, we're looking for the opposite. We have the hypotenuse. The trigonometric identity we'll be using is sine. So the sine of 30 degrees is equal to opposite over a hypotenuse. In this case, it's 20. So O is 20 times sine 30 degrees. So O, in this case, is 20 sine 30 degrees. So this is equal to 10. So it has traveled north exactly 10 meters. So therefore, it has traveled north 10 meters. Therefore, I'm just going to write travel north 10 meters. Travel north 10 meters. And that just doesn't, that means it's traveled north 10 meters from where it started. So we know it's gone 20, but the distance from its origin to where it is now, just directly north or directly in its vertical line, is 10 meters. For west, same concept, but instead we're using the adjacent. And so in this case, we are using cos of 30. So cos 30 degrees is equal to the adjacent of 20. So A is equal to 20 cos 30 degrees. And so our A is equal to 17.32. 17.32 meters. So therefore, traveled west 17.32 meters. Again, we're just assuming that it's to 2 decimal places, unless the question specifies. In this question, it doesn't, so just assume 2 decimal places. Alright, last 2 questions here, question 14 and question 15. Question 14, we're going to find the values, or I should say value rather, of the letter X here. Now we can tell that there is a right angle triangle that we're dealing with. The only problem is the length of X doesn't take the full required length here of the bottom. So to find the value of X, now this question, we can see that it doesn't have anything to do with trigonometry because there are no angles involved. This is a segue that leads into question 15. We're going to work on our Pythagoras theorem. So remember, with Pythagoras, we need to find a certain length of some sort. We know that c squared is equal to a squared plus b squared. Or c is equal to the square root of a squared plus b squared. And remember, c is the hypotenuse, so always the longest length, and AB could be any one of those two. Now within here, the length that we do have is 10 for this left hand side, sorry. We've also got 16 here, which is the hypotenuse of the bigger triangle. And we've also got 14 here, which is the hypotenuse for the smaller triangle. And so what we need to do is, in order to tackle this, using this or changing this this formula around, we need to get the length of the bottom here of the full thing. Okay, so using the 10 and the 16, and then we have to get the length of this shorter length here, which is using the 10 and the 14. And to get the X, we have to find the difference of the longer line, take away the shorter line. Okay, so that's all we need to do. Now, the hypotenuse has been given to us. Okay, so C has been given to us. So we're not necessarily going to be using this formula. We're going to be using the other formula whenever we need to find a shorter length, depending on whether it's A or B. It is A squared is equal to C squared take away B squared. Or B squared is equal to C squared take away A squared. Or in other words, A is equal to the square root of C squared take away B squared. Right, so this is the formula that we have to use in order to tackle a question like this. And so let's go ahead and try to figure out what this length here is. So from A to D. So length AD, we need to we can work that out. AD, this is equal to the square root. Now, C squared take away B squared, it's 14, which is a hypotenuse, because C is always counted as a hypotenuse, it's always the longest side. It is 14 squared. Take away what this side is, which is 10 squared, or square rooted. And you can do this in one hit using your scientific calculator. So square root of 14 squared, take away 10 squared. And what we're left with is 4 square root of 6, or 9.79, or 9.8. So this is 9.8. Now there's no units here, there's no meters or centimeters, so we just leave it as 9.8. Okay, so we've got A to D. Now we need to get A to C. So A to C, this is the square root of the longest side squared, which is 16, take away the shorter side, which is 10. This is square root of 16, square root of 16 squared, take away 10 squared. So you grab a calculator, square root of 16 squared, take away 10 squared. Pressing the SD button will give us 12.48, or 12.49 when rounded. 12.49. So the length of X, we've figured out that this longer line is 12.49 and the shorter one is 9.8. To get this length from there to there, DC, all we need to do is just find the difference between 12.49 and 9.8. Alright, so find the difference between these two. 12.49 take away 9.8, and we're left with 2.69. This isn't a worded type question, it's just a scenario type question or a diagram type question, so you don't have to write it in worded format. So 2.69 is final solution. So we're using this Pythag. I've thrown this in here so we can recall our Pythag skills in order to tackle a question like this. So question 15, it's Pythag in 3D. Not Pythag, sorry. A bit of Pythag in 3D, but trigonometry in 3D. And here we've got this cuboid with dimensions. We've got 8, 9, and 14. And what we're trying to do is we're going to use Pythagoras' theorem to try to find the length of B to G. So from B to G. Now, we can see that there is, I'll just push this inside so we can indicate that this is the previous question. We know that there is a right angle within there. So if you were to look at this bird's eye view, and assuming it's made out of glass or some sort, the triangle that we can see here, the right angle triangle, is we've got an 8 centimeter length here, which is that there. We've got the 9 centimeter here. And this is the length that we're looking for. This length here, B to G. So BG is equal to the square root of A squared plus B squared, or 8 squared plus 9 squared. So straight into the calculator, square root of 8 squared plus 9 squared. And this will give us 12.04. 12.04, and our unit in this case is centimeters. So BG, this length here, is 12.04 centimeters. Okay. And now with this line, we're going to use that line, hence use BG to find this angle here, theta. So if I were to then extract that triangle out, with theta being this angle here, obviously we're going to have to use an inverse trigonometric identity because we're looking for an angle. We've got the height, which is 14. So this height here is 14 centimeters. And that bottom length is that diagonal that goes across from corner to corner of the cuboid. We worked out what that is, 12.04. This is 12.04. And so in relation to this angle here, we have been given the opposite and the adjacent. We're going to be using tan inverse. So tan of this angle is equal to 14 over 12.4. Or in other words, the theta is equal to tan inverse of 14 over 12.04. And so remember that 12.04 we used by using Pythag. Pop this into the calculator. And we've got 14 over 12.04. And we're getting is 49.30. So 49.30. And this is an angle, so it's degrees. And there's our final solution. Again, this isn't a worded question. It's just a diagram, so you can leave the solution just at that. So hopefully you guys did really well with this this practice test. Real test will happen in class when we go back into class. No idea when that's going to be. Until then, I'll see you guys in the next potential video. Bye.